Hello everybody and welcome to this second video on applications, part 2. So today we're going to talk about marginal analysis. This is an economic related concept on which we can apply some interesting calculus ideas. So little introduction basically before we go on. Let's talk about vocabulary in this section, vocabulary. So the terms that we are going to basically need in order to pursue our study of this. So we have different variables in here. We have something that we call a cost equation. Cost equation. Cost equation, which is actually made of two things. For those of you who studied economics a little bit, you know that the cost is actually made of a fixed part, and also a variable part. So something that actually will depend on how many units you produce, right? So obviously, if you produce 500 or 5 million, the variable cost will be different. And the fixed cost, well, this is what we actually called fixed costs. They're going to be the same. They're not going to change if you produce 5,000 or 5 million. Electricity, rent, city taxes, water taxes, that kind of thing, right? So cost equation, we also have a concept called revenue. So we will have a revenue equation as well. Revenue is always defined as, how should we define revenue? Suppose that you have a little one of these, like, things that you roll into the park and you sell ice cream to the people that are in the park. Suppose you have 200 popsicles in there and you sell them $5 each. Well, at the end of the day, if you sold everything, you sold 200 popsicles at $5 each, you have $1,000 in terms of revenue. This is not net money in your pocket, but it's what we call the revenue. So the price that you sell each popsicles, so $5, multiplied by the number of popsicles you sell. So we call this price times quantity. We also have something called, obviously, a profit equation. Now, what is profit per se? Revenue is not profit. Profit is actually the subtraction of the cost from the revenue. So we call this money that goes in versus money that comes out of your pocket. So this is the $1,000 that you actually got from selling 200 popsicles at $5 each, but you have to pay for the popsicles that you bought, you have to pay for the cart because you rented it, and so on and so forth. So what's left at the end of the day is what we call the profit. Also, finally, there is a concept that we call demand or supply equation. We're not going to go into details of this. You'll study this a lot more in Calculus 2 and also in an economics class. But this is just basically a function p of x, where p is the price and x is the quantity. So it's a function of price versus quantity. In other words, as common sense dictates, if the price is really, really high, less people will want it. If the price is really, really low, then more people will want to buy the item. So X will grow when P goes down. That's the standard demand equation. Okay, so all of this can be put into a nice little context in terms of a problem. Let me get rid of this and we can take a look at a particular situation that I have ready for you guys. So let's consider the following situation. So a company, situation. So a company produces, I don't know, whatever, gizmos, for the lack of better words, gizmos. And the number of gizmos that they actually produce is unknown, but we know that there is a cost equation where the cost equation is known to be, where the cost equation is known to be, we're going to write this as C of x, let's say 350 plus x squared plus root x, where x is the number of gizmos produced. I don't know if I spelled gizmos correctly. Gizmos produced. So we have this equation here. Let me see if my red one works a little better than last time. A little bit. Still need a new marker, I think. So this is my cost equation, and that cost equation basically determines how many of the gizmos, depending on how many of the gizmos that I make, what's going to be my cost. You can see here that the 350 is my fixed cost. This does not change, right? And that other portion with the x's, that's what we call the variable cost. Okay, so here's a little question here. Find the cost of producing 0 items. Find the company's cost. Find the company's cost for producing 0 items. Well, if you produce 0 items, you don't have to buy the raw material to build what you build. So maybe your gizmos are made of plastic. You're producing 0, you don't buy plastic. But you got to pay rent, and you got to pay the water tax, and you got to pay the city tax, and you got to pay those things, electricity, because you got to heat the place in winter anyway, that you're there or not. So what we get here is C of 0, because remember, X is the number of gizmos that you produce. Here we produce 0. So clearly my cost is not going to be 0 because of the fixed cost. So the answer to this is $350. So even if you produce nothing, you will incur some costs for that. That's guaranteed. Okay, good. So why don't we take a look at something more realistic. So find a cost of producing, find the cost of producing, let's say 100 gizmos. What is the cost of producing 100 gizmos? Well, this is my cost equation. X is 100, clearly. So C of 100 is going to be 350 plus 100 square plus the root of 100. Well, that's what, 10,000. So 10,350. So 10,350 plus 10. So 60. That's your cost of producing 100 gizmos. All right, continuing our little investigation here with something that you might actually find to be, not so really worthwhile, but trust me, it opens the door to the calculus application of marginal cost. Find the cost of producing, this time, 101 gizmos. Okay, a little repetitive. So instead of C of 100, this is C of 101. So we go 350 plus 101 squared plus the root of 101. We calculated that and we get something like $10,561 and I do believe 5 cents. All right, So we can calculate the cost of producing a number of items if we have the cost equation. What's going to be interesting is actually to use those last two questions to figure out a fourth one. Let me put it over here so that I still have it before my eyes. I will erase the rest in a moment, but I'd like to have those two on the same whiteboard. Now this is interesting. Here's the question. Different. Pay attention. Find the exact cost involved in producing, so the exact cost involved in the production, in producing the 101st gizmo alone. Only that one. Only this one. So I can't do C of 101, huh? Because C of 101 is the cost of producing 101 items. So what is the cost of just that one item, which is item number 101? Well, think about it. If I use C of 101, that's going to be the cost of producing 101 items. And if I subtract from that the cost of producing 100, shouldn't I have the cost of producing the one item difference from 100 to 101? Clearly, the answer to this is C of 101 minus C of 100. That is qua 10,561.05 minus 10,360 flat. And what is that? This is $201.05. Okay. So what is this? This actually is precisely what it would cost me to do. So let's interpret that with the sentence. This is what it would cost us to do if I wanted to produce one more item once I have produced already 100. In other words, the 101st item. So $201.05 is the exact cost of producing one more gizmo once I have already produced 100 gizmos. So once I have already produced 100 gizmos, right? i.e., it's the cost of producing, like we said before, the 101st gizmo. The 101st gizmo. Okay, now that's interesting because it relates to calculus. That's the only reason why this is interesting to a mathematician or to students in mathematics. Cool. So let's leave that behind. I need the entire whiteboard to actually do what I need to do next without being interrupted by the shortness of this thing. So let me get rid of this and let us see how this can actually be related to calculus. Now remark. C of 101 minus C of 100. What is that? This is the exact cost producing, making, manufacturing, call it what you will, the 101st gizmo. All right. Now, this is actually equal to C of, let me rewrite this differently, 100 plus 1. Yeah, I don't like it. 1 comes up, minus C of 100 over what? What is this over? It's over 1, right? Because it's over nothing. It's over 1. Okay, this is a strange way of writing the exact line above. All right? So, again, remember, keep in mind, you're bright people, you know this. I'm trying to connect something to calculus. So, I'm going to say this is C of x plus h minus C of x all over h for or when x is equal to what and h is equal to what. Compare this to this. What did I do? I let x be 100 and I let h be 1. I let x be 100 and I let h be 1. Aha, perhaps you recognize this a little bit because f of x plus h minus f of x over h is something well known to us. What it is missing is a limit in front of that. And what would it be if I put here the limit as h goes to 0? It would be the limit definition of the cost function. Aha. So this is, I'm going to put here like a wiggling sign here. This is almost equal to the limit. I should put that in green. Huh? To the limit as h goes to 0. Actually, not true. Well, yeah, true. Of C of x plus h minus C of x over h. Put an h here. Put an h here. So basically, without the limit, clearly, this is not equal to that. This has no limit. This does. But if I put a limit here, meaning if the h is very, very small, then those two can actually be equated to each other, and this is actually the derivative of the function c. It is the c prime, the derivative of c. And this is called c prime. This is called in the literature, this c prime dude, yeah, this is called the marginal cost. This is called the marginal cost of the function c of x, obviously. So the marginal cost is this. What it does, it provides, now remember this symbol here. This symbol here means what? Approximately equal. Not exactly equal because this doesn't have a limit and this does. So it provides what is called an approximation. It provides an approximation to what? Well, the original quantity that we were trying to figure out, to the exact cost, to the exact cost of producing the x plus first item, gizmo, whatever. So it's supposed to produce an approximation. Now, we already calculate the exact cost. I'm going to bring back the stuff that we did before, and we're going to compare that to the C prime value. And we're going to see that they're actually fairly close to one another. So let me do that right now. let me get rid of all this. So recall, I recall two things actually. So recall that our cost function was given by what? 350 plus x squared plus root x. Also recall the exact cost of producing the 101st item, which was, I believe, $201.05. Recall this. Now, C prime of x is supposed to approximate, C prime is supposed to approximate, so approximates C of x plus 1 minus C of x. So let's calculate C prime. Well, that's a derivative of C. So that's a derivative of 350 plus x squared plus root x. Nothing difficult here. That's 0. That's 2x. And the derivative of root x we've done a gazillion number of times, so please allow me to go directly to the answer, 1 over 2 root x. And now we have already produced how many items? We have already produced 100 items. So, and we want to know the approximate cost of producing one more. So if we've already produced 100 items, I would like to figure out what is C prime of 100. So that's going to be 2 times 100 plus 1 over 2 times the root of 100. That's 200 plus 0.04. That's 0.05. 1 over 20, sorry. 1.05, so that's $200.05. So compare this to that. Compare the exact to the approximate. Compare the exact and the approximate. So this is the exact price of producing the 101st unit, and this is the approximate price of producing the same thing, the 101st unit. You will see here that the difference is minimal. Difference of only what? 201.05 minus a dollar. Difference of only $1. So I conclude that the approximation is good. It's a good approximation. So the marginal cost, this is your marginal cost right here, C prime, right? We defined that in the previous board. C prime is your marginal cost. It ends up approximating the exact value by a dollar. A dollar over 200 is half of 1%. So it's a pretty good approximation. All right. So that's good as a first introductory example. Now let's take a look at something perhaps a little more involved with more economics function in the picture. So example. So a company, once again, makes I'm running out of words, gizmos, things, we'll call them bidule. In English, of course, this is known as bidule. That doesn't make any sense. Call it whatever you want, okay. So it makes bidule with a variable cost. With a variable cost. of $10. What does that mean? It means that in terms of raw material, to build one bidule, you actually need to pay $10. And fixed costs of 150. And fixed cost of $150. So with these two things, we should be able to build the cost equation, because cost equation is fixed plus variable. Very good. Okay, now we also know that the demand equation for the bidule, the demand equation for X bidoules is given by P is equal to, say, minus 2x plus, say, 300. All right, excellent. So find from this the cost equation the revenue equation and the profit equation. So now we're into more interesting economic concept. One little detail before we go on. In the demand equation, P stands for price. Right, so perhaps I should write this down. P here stands, yeah, this red is finished, for price. Let me put that in black. Price, and my X is the usual quantity, Q. Quantity. Typical language of economics. Okay, so how do I find the cost equation? Cost equation is what? Fixed plus variable. So $10 is my variable cost. How many do I make? I make X, so 10X plus my fixed cost of 150. That's my cost equation. My revenue equation is the price times the quantity, which makes Parti Québécois. It's not exactly synonymous of revenue in this province, is it? P, I have an equation for that, minus 2x plus 300 times Q. Well, we just said that Q is always the quantity, so I get minus 2x squared plus 300x. And finally, profit is revenue minus cost, so revenue minus 2x squared plus 300x minus my cost, which is this 10x plus 150. So my profit equation, it is with this that I want to work, shall be minus 2x squared. Check it out, 300 minus 10x, because I'm going to take the minus inside the bracket, is 290, sorry, minus 150. Okay, that's my profit equation. Hope I didn't go too fast over this. Revenue minus cost. All right, so I'd like to ask a few more questions on this. Namely, what is the profit generated from selling or making, let's suppose it's the same thing, 50 bidules, also known as bidoules. So this is a level of 50. That means that my X is 50. That means that my profit equal minus 2 times 50 squared plus 290 times 50 minus 150. What is this equal to? This is equal to $9,350. What is the profit? What is the profit generated from selling, 51 of these bidule? Well, now x is 51, so profit is minus 2 times 51 squared plus 290 times 51 minus the fixed 150. Now if you calculate that, you're going to get 9,438. So interesting. You can see me coming here. So the difference between 50 and 51. So I'm going to be asking 2 more questions out of this, which I will put on the same whiteboard. I don't like to do that, but I need the information that is still here for question 6 of this one. Find the exact profit. Find the exact profit generated from making, from selling, from making the 51st bidule alone, just this one. So you want the profit from doing the 51st, so you're going to have to go C of 51 minus C of 50, and that'll be the difference between those two amounts. So 94.38 minus 93.50. So the profit from making the 51st alone is $88. Finally, use the concept of marginal profit to approximate the quantity in 6. So marginal profit, we have defined this as profit, what? Prime. In other words, minus 2x squared plus 290x minus 150. This must go prime. What the? Okay. All right, so that's an easy derivative. So marginal profit, or profit prime, is equal to minus 4x plus 290 plus 0. So since we've already produced 50, since we already produced, sold 50 bidule, and we're actually interested in finding the profit from the 51st, we go profit prime when x is 50 will give us minus 4 times 50 plus 290. What is that? That's minus 200 plus 290, that's $90. And once again, you can tell that those two amounts are relatively close to each other. So this is the approximate value, while the other one is the exact value. So remember, when you're doing marginal analysis, you put in the number of things that you have already produced in order to figure out the cost of the next one, of the 51st one in that case. So you don't want to put in x is equal to 51 in there, because that would give you the cost of producing the 52nd item, which is not what we want. Okay, we'll do some more of these in class. That's it for today. Thank you for your attention, and I'll see you next time.